In 1989, a Japanese manufacturer unleashed the Lexus LS400. It wasn't just a car, it was a declaration of war on everything the luxury world believed about itself. Before that moment, the automotive world was simple. You had cheap cars that worked and expensive cars that broke but had status. Then came this challenger. They didn't just want to join the club, they wanted to burn the clubhouse down. This is the story of lost luxury. It is about a time when engineers were given blank checks and told to chase perfection. But before we get to what made this car so dangerous, you need to understand what the luxury world looked like before it arrived, because the contrast is everything. The automotive landscape of the early 1980s was a stagnant place. In North America, the domestic giants were stuck in the malaise era. Cars like the Cadillac Fleetwood or Lincoln Town Car were caricatures of luxury, enormous boats covered in velour and fake wood. Their engines were choked by emissions equipment, offering little power. Build quality was poor, plagued by indifferent assembly and rattling dashboards. Comfortable, yes, but imprecise. Across the ocean, West Germany held the high ground. Mercedes-Benz and BMW operated with a different mindset. They used a cost-plus system. They designed the car they wanted to build, tallied up the cost, added a healthy profit margin, and passed that price to the customer. They believed that luxury was defined by the badge on the hood. They assumed that customers would always pay for the privilege of German engineering, even if the electrical systems were fragile. They felt untouchable, secure in the knowledge that no one else had the heritage to challenge them. But the catalyst for change did not come from a design studio. It came from a trade agreement. In 1981, the American government tried to protect Detroit automakers by signing the Voluntary Restraint Agreement. This policy put a hard limit on the number of cars Japanese companies could export to the United States. The goal was to stop the flood of cheap, reliable economy cars and give American companies room to breathe. It was a massive miscalculation. The agreement limited the volume of cars, not the value. Toyota looked at the math and realized the strategy had to shift. They could no longer rely on selling millions of cheap Corollas to make a profit. Since they could only ship a fixed number of vehicles, each one had to be worth more. To survive the restriction, Toyota had to move up market. The law intended to save American luxury brands inadvertently forced Japan to build a competitor. It gave Toyota the motive to invade the highest sector of the market. With the target identified, Toyota needed a weapon. Instead, the law handed Toyota a blueprint for something no one had ever attempted before. And the company chairman looked at his team and issued a command that seemed impossible: ignore the budget. The answer to that command began in August 1983. EIG Toyota summoned his top executives and engineers to a secret meeting. He did not ask for a better Corolla. He did not ask for a slightly more comfortable sedan. He asked a question that bordered on arrogance. He asked if they could create a luxury car to challenge the very best in the world. This was the birth of Project Circle F. In modern manufacturing, a new car project usually involves strict budgets and tight timelines. This project had neither. It was a mobilization of resources that looked more like a wartime effort than a product launch. Over 6 years, Toyota assigned nearly 4,000 employees to this single task. In a typical development cycle, an automaker might build a few dozen prototypes. For this project, they built 450 full-scale cars and 900 engines. They were trying to brute force their way to perfection through sheer volume. The budget ballooned to nearly $1 billion. This was an era where modern financial constraints simply did not exist. The man charged with spending this fortune was Chief Engineer Ichiro Suzuki. He refused to accept the traditional compromises of automotive design. In the past, engineering was a zero-sum game. If you wanted high speed, you had to sacrifice fuel economy. If you wanted a quiet cabin, you had to add heavy insulation, which made the car slow. Suzuki rejected this trade-off. He established the source philosophy, also known as the Wyatt philosophy. He demanded a car that could reach 155 miles per hour, yet deliver 22.5 miles per gallon. He demanded a car that was aerodynamic enough to slip through the wind. yet possessed the traditional upright stature of a luxury limousine. He wanted a cabin quieter than a Rolls-Royce, yet lighter than a BMW. To his team, these targets seemed physically impossible. They argued that the technology to achieve them did not exist. Suzuki told them to invent it. The testing process was ruthless. They shipped entire fleets of prototypes to Germany to run on the Autobahn at maximum speed. When they found a vibration or a noise, they did not just add more sound deadening. They traced the problem back to the source. They would analyze the casting of a metal part or the shape of a mirror. They would redesign the component, build a new prototype, and test it again. If it still was not perfect, they crushed the car and started over. This was the definition of a blank check mandate. The goal was absolute supremacy, regardless of the cost. It is a way of thinking that has largely vanished from the industrial world. Today, efficiency is the primary metric. In 1983, the primary metric was excellence. But this philosophical commitment to perfection had to be forged in metal, and nowhere was this more apparent than in the engine bay. To compete, the car needed a V8, but Toyota had almost no experience building high-performance 8-cylinder engines. Their existing large engines were heavy iron blocks used in domestic limousines or trucks, durable but agricultural. For this car, the engineers started from a clean sheet. The result was the 1UZFE. This was a 4-liter, 32-valve, all-aluminum V8. To its mechanical engineers, this engine is not just a machine, it is a masterpiece of metallurgy. It represents the physical embodiment of the lost luxury philosophy. Today, modern engines are designed with cost-effective manufacturing as a primary goal. They use powdered metal connecting rods and cast iron crankshafts because those materials are good enough to last through a warranty period. The designers of this engine were not interested in what was good enough. The engine block utilized 6-bolt main bearing caps. In a standard V8 engine, including the legendary American engines of the past, the caps that hold the crankshaft in place are usually secured with 2 or 4 bolts. Using 6 bolts provides an immense amount of clamping force. It ensures that the crankshaft remains perfectly stable, even under extreme loads. This is the kind of architecture typically reserved for racing engines, not luxury sedans designed for the school run. The crankshaft itself was forged from steel and featured 8 counterweights. Most production engines use cast iron cranks with fewer counterweights to save money. The forged construction made the part incredibly strong, while the extra counterweights eliminated secondary vibrations. The connecting rods were sintered and forged for density. The pistons were made from a high silicon alloy that allowed for tighter tolerances. This meant the engine could be built with less space between the moving parts, reducing the noise and slop that develops over time. All of this over-engineering might sound excessive, but there is one way to prove it actually mattered, and it involves the FAA. The ultimate proof of this over-engineering is found in the sky. This engine is one of the few automotive engines ever certified by the FAA for use in aircraft. In aviation, failure is a catastrophe. That a luxury sedan motor met aerospace reliability standards highlights the massive gap between this machine and its contemporaries. This obsession with vibration damping was not just theoretical, it was marketed to the world through a commercial that became a legend. The advertisement showed a pyramid of crystal champagne glasses stacked on the hood of the car. The engine was revved to the equivalent of 145 miles per hour on a dynamometer. The glasses did not move. It was the result of liquid-filled engine mounts tuned to absorb specific frequencies and a driveshaft angle adjusted by fractions of a degree. This mechanical perfection extended into the cabin. Engineers focused on the tactile experience of every control, testing dozens of damping greases for the switchgear. They ensured the volume knob and window switches offered the same viscous, heavy resistance, mimicking high-end home audio equipment. The grease had to maintain its thickness in freezing cold and blistering heat, ensuring the feel never changed. Even the wood trim was treated with a level of seriousness that seems foreign today. The brand partnered with Yamaha, the musical instrument manufacturer. The wood veneers were not just plastic-coated strips. They were sliced from the same stocks used for concert grand pianos. They underwent a multi-stage curing process that gave them a depth and luminosity that synthetic materials cannot replicate. Every surface was designed to tell the occupant that this object was built by people who cared about the smallest details. The engineers had done their job. Now came the moment of truth. When this machine finally arrived in Detroit in January 1989, the industry was expecting a competent Japanese car. They were not expecting a revolution. The car looked conservative on the outside, perhaps even a little boring. But then the company announced the price. The car would start at approximately $35,000. The room gasped. At that time, a BMW 7 Series cost over $54,000. The Mercedes 420 SEL was over $61,000. The new Challenger was faster, quieter, more fuel efficient, and avoided the gas guzzler tax. And yet, it cost nearly half as much as its German rivals. This pricing strategy sent a shockwave through the industry. It was not just a competitive price, it was a destructive one. The German manufacturers panicked. BMW accused the company of dumping, of selling the cars below the cost of production to steal market share. Mercedes-Benz took an even more drastic step. They were preparing to launch their next-generation S-Class, known as the W140. Upon seeing what the Japanese had built, Mercedes delayed their own launch to re-engineer their car. The panic was real. The established aristocracy realized their profit margins were based on a lack of competition, and that era was over. However, the launch was not without a crisis. In late 1989, despite the billion-dollar development budget and the relentless testing, 2 minor defects emerged in the first 8,000 cars sold. There was a faulty connection in the cruise control system and a warping housing on the third brake light. In the standard corporate playbook, this would be handled quietly. The company would issue a technical service bulletin and fix the cars when the owners came in for an oil change. The company chose a different path. They viewed this as a threat to their honor. They issued a total recall, but they did not ask the customers to bring the cars in. The dealers telephoned every single owner personally. Technicians were dispatched to owners' homes and offices. They picked up the cars, performed the repair, washed the vehicle, filled the gas tank, and returned it. In some cases, they even rented garage space in remote areas to service cars that were far from a dealership. This response turned a potential disaster into a marketing triumph. It proved that the brand cared more about the customer's experience than their own service costs. It set a standard for customer service that the rest of the industry is still chasing. The LS400 was a triumph, but the real proof of its philosophy came later, and it revealed something darker about where the industry went next. One car, driven 1 million miles, would show us what lost luxury actually means. The ultimate proof of this philosophy is the million-mile Lexus. This 1996 model was driven across the country until the odometer rolled over to 1 million miles. When the engine was finally opened for inspection, the factory cross-hatching marks were still visible on the cylinder walls. After 1 million miles, the metal had barely worn down. It is the luxury of an engine that refuses to age, proving that planned obsolescence is a choice, not a necessity. This story highlights that lost luxury is not just nostalgia, it is a quantifiable shift in engineering priorities. In the 90s, cars were designed with a fatigue limit that assumed decades of use. Wiring harnesses were over-insulated. Connectors were gold-plated. Today, manufacturers design for assembly speed. Modern luxury cars use plastic intake manifolds that crack after 10 years. Some manufacturers claim transmission fluid is lifetime, which is a lie designed to lower ownership costs on paper. The LS400 has a dipstick and a drain plug. It invites maintenance because it was built to last. The driving experience also reflects a lost era. The car was designed to isolate the driver from the world completely. It used soft suspension and tall tires to float over the road. Modern luxury cars are obsessed with sportiness. They have stiff suspension to achieve lap times on racetracks that no owner will ever visit. The LS400 knew what it was. It did not try to be a sports car. This commanding presence is why the chassis remains popular in Japan today. The VIP or bipu culture keeps these cars alive, modifying them into rolling lounges with curtains and deep-dish wheels that demand respect on the street. The industry has simply moved on, but the artifact remains. What did we trade away for efficiency? The Lexus LS400 is a ghost of a specific economic bubble where engineers ignored accountants. We do not make cars like this anymore. Modern demands consume the budget that used to pay for forged steel. It remains a reminder of a brief moment when the goal was perfection rather than profit. If you want to see more stories about the craftsmanship we left behind, please subscribe to the channel.